Hello guys, here's a brief video implementation for ICP-14, which is module 2 ICP-7. Cause my microphone has some issues, so that's why I use my mobile phone for recording this video. So let's just quick to take a look at the ICP questions. So we have to use several machine learning models to apply on those dataset which the lesson plan gave us. So the first one is gonna be we're gonna use a naive Bayes to the adults dataset. As what you can see here, like the dataset is read from the CSV file, which is from the adult CSV, and then the algorithm is like basically based on the naive Bayes, like everything is recreated the model, and like we use this data set, and an RDD is created, and RDD is like a label point is given as the input, and naive Bayes model will generate the output. So it's like that's how the code looks like. It's not that large because it's written in Python, and it can be seen like the age, which is one of the field in the CSV file, and is renamed it as the label and particular columns such as hour per week. Next step, the data will be split to perform both training and testing phase, and then finally the model is fed and the accuracy is generated. But because the video is brief, so I cannot like run each model and generate output each time, and because it's gonna take long. But like you can visit my wiki page, which I gonna post a link in the the ICP submission form. And yeah, so the next one we're gonna come to the decision tree. The decision tree is gonna be like that. It's pretty like straightforward, and like decision tree is like a greedy algorithm that perform the recursive binary partition. Like each partition is chosen greedily by selecting the best split from a set of possible split. So we have in order to maximize the information gain at a tree node, RDD as like the given input, the education time, and the decision tree classifier is run, and the output is generated also, and that's mainly the code, which is very similar to the naive Bayes but different models. um like the next one we can come to the random forest, but like I didn't have the file here, so it's just fine. We can go to the clustering part, which is like the k-means is like that, which is it's also very similar, like the model training, testing, splitting data, getting the RDD, and like, but in k-means we have the like k-means vectors, a vector create for the sake of the feature columns, and training is done and the model is fitted. Finally, the prediction will be made it. Like as you can see here, is like the prediction data is here, and the vector assembler is gonna be there. It takes like all features vectors, and we come to next one, the regression. Regression is like logistic regression or linear regression. We come to linear first, and it's like yeah, you just take those data, and then number of the maximum iteration are given, which is 10 in this case, and the transformation is performed on data, and data will be fitted, and we have no error in this case. And we come to logistic, which is gonna be for me. Logistic. Let's go through it quickly. That which is basically using logistic function to model a binary dependent variable, and although like many more complex extension exist, this code is just run on a fitted data. So like the data is taken from a CSV file, which is already given, and like yeah, it will be more simple to implement. But like yeah, that's like I've done in ICP-7. If you have any more question, just let me know and I will explain it later. And like, thanks for watching it. It's very brief and very rough, and like, yeah, thank you. Just, yeah, be safe. Good luck.